Hey everyone, and welcome back to the channel. Today, we re-diving under the hood to demystify one of the most brilliant inventions of the modern age. The petrol engine. It's the heart of most cars on the road, but how exactly does it turn a splash of fuel into the power that gets you from A to B? Well, get ready, because we're about to break it down. At its core, a car engine is a type of internal combustion engine. The name says it all. It creates power by burning fuel inside the engine itself. This process happens inside cylinders, which are essentially strong metal tubes. Inside each cylinder, a piston moves up and down, and it's this movement that ultimately turns your wheels. Most cars today use a four-stroke engine, which means the piston completes, for distinct movements, or strokes, for every single power-producing cycle. Let's walk through them. It all starts with the intake stroke. The piston moves down inside the cylinder, and an intake valve opens. This creates a vacuum that sucks in a fine mist of air and petrol. Think of it like drawing back the plunger on a syringe. Next up is the compression stroke. The intake valve closes, and the piston moves back up the cylinder, squeezing that air and fuel mixture into a much smaller space. Compressing this mixture makes it highly volatile and ready to release a ton of energy. This is a crucial step. The more you compress it, the bigger the bang you'll get. Then comes the magic moment, the combustion stroke, also known as the power stroke. Just as the piston reaches the top of its compression stroke, the spark plug fires. It creates a tiny, precisely timed spark of electricity that ignites the compressed air-fuel mixture. The result is a powerful explosion. This explosion forces the piston down the cylinder with incredible force. This is the stroke that actually generates the power to move your car. Finally, we have the exhaust stroke. After the explosion, the cylinder is full of burnt gases. The exhaust valve opens, and the piston travels back up the cylinder, pushing all those waste gases out through the exhaust system. Once the piston reaches the top, the exhaust valve closes, the intake valve opens, and the whole cycle starts all over again, ready for the next intake stroke. Now, your car's engine has multiple cylinders, usually 4, 6, or 8. Each cylinder is firing at a different time, creating a continuous and smooth delivery of power. All these pistons moving up and down are connected to a crankshaft. The up and down motion of the pistons is converted into rotational motion by the crankshaft, much like how your legs push pedals to turn the wheels of a bicycle. This rotation is then sent through the transmission, to the drive shaft, and finally to the wheels, propelling your car forward. But what about keeping everything in sync? That's the job of the timing belt or chain. It connects the crankshaft to the camshafts, which control the opening and closing of the intake and exhaust valves. It's a beautifully choreographed mechanical dance, ensuring each valve opens and closes at the exact right moment for each stroke of each piston. It's absolutely critical for the engine to run smoothly. And of course, an engine generates a massive amount of heat. That's why cars have a cooling system, typically using a liquid coolant like antifreeze mixed with water. This coolant circulates through passages in the engine block, absorbing heat and carrying it to the radiator at the front of the car. There, airflow cools the liquid down before it's sent back to do it all again, preventing the engine from overheating. At the same time, all those moving parts need to be lubricated to reduce friction and wear. The engine's oil system pumps oil to all the critical components, like the pistons, crankshaft, and camshafts. This thin film of oil allows everything to move smoothly and last for thousands of miles. So, to recap, intake sucks it in, compression squeezes it tight, combustion creates the big bang, and exhaust pushes it out. This four-stroke cycle happens thousands of times per minute, with all the engine system's timing, cooling, and lubrication working in perfect harmony to turn simple petrol into motion. It's an incredible piece of engineering that has powered our world for over a century. And there you have it, the fundamental principles of how a petrol engine works. It might seem complex, but it's all based on these simple, powerful steps. I hope this gave you a clearer picture of what is happening under the hood of your car. If you found this interesting, give this video a thumbs up. Do you forget to subscribe and hit that notification bell so you do miss our next deep dive. Thanks for watching, and we'll see you in the next one.